Welcome back, everyone. In this second video on cellular IoT with embedded Rust, we're going to look at setting up a debugging probe flash applications to our development kit. Cargo run is going to invoke the probe run crate. Probe run is built on the probe.rs library. So if we come here to the probe.rs website, come here to the docs page, and we can see if we're running on Linux, we need to install some udev rules so that we can operate the debugging probe without having to use sudo. So follow these instructions. It will give you a file to download and install into your udev rules.d directory, as well as a couple commands to make sure that those rules are loaded properly. Once we've got all this set up, we can come here and we'll run LSUSB, and we can see here that right here is our J-Link device, which is our debugger, and it's running on bus 2 and is device number 10. Next, we're going to run the ls-l command for bus 2 device number 10, and we can see here that it comes back with the plug dev permissions, which is exactly what we want to see. So we've got our debugging probe with the correct permissions. There's a couple ways that we can flash our development kit. If we go back to the probe.rs library website, we can see here that there's a couple of tools provided by probe.rs. One is Cargo Flash. Cargo Flash is an extension and drop-in replacement for Cargo Run. So what this will do, we can do cargo install Cargo Flash, and when we run that, it will flash the application to the processor. The Cargo Embed tool is the big brother of Cargo Flash. It can also open an RTT terminal as well as a GDB server, and it has an embed.toml file where you can set up certain configurations. So if we're back to our IDE, we've got Cargo Flash installed. So what we can do is we can run Cargo Flash. We're going to provide the chip type, and then we're going to say we want to flash the binary AT client. It erases the sectors and then flashes the new application. Complete. Notice that the program is not running. Now if we run cargo run release binary using our alias shorthand command, AT client, it will not only flash the program, but it also will immediately run it. Now that we have our AT client binary flashed to our development kit, I'm going to go over what it's doing. The AT client application is developed to work with Nordic's LTE Link Monitor application, which helps you debug your cellular communications. It's based on UART. It's using serial communication to just pass commands from LTE Link Monitor to the modem and then pass the modem's response back to the application. I've got it set up for the Connexio Stratus, which uses pins 5 and 6 on port 0. If you're using an Icarus or Thingy, I've got the pins in the comments here. We're going to need the NRF Connect apps from Nordic. On their website, you can find the documentation on how to install and everything. It includes stuff like, here's our LTE Link monitor and our power profiler, and we also have a programmer. So once you get that downloaded and installed, you can bring up the NRF Connect application. Once you have it open, you can see all the individual tools it includes, and you can create a shortcut and put it on your desktop. Now once you have all that installed, we're going to open the LTE Link monitor, and we're going to select our device. Here it's shown as unknown. The J-Link here is our debugger, but we're actually using the USB cable to communicate. That's because we have a USB to UART serial chip on the development kit, and that's how we're going to be using our UART. So you can see here that it ran the cfun command and it came back with OK, so we know everything's working. Down here we have a memory bank where we can store commands that we use a lot. cfun equals 0 turns the modem off. cfun equals 1 is turn the modem on. So if we turn the modem on and we run this, the application will run a bunch of different commands to get it in a good state for tracking how it's connecting. We have a chart here which will show our signal strength as well as certain events when we connect to a cellular network. Back here in our AT command terminal, we can look at our modem software version. You can see here that my board is loaded with the newest version, which is 1.3.5. And they recommend if you update to 1.34 or newer, I think it is, they suggest that you have a certain hardware version. If you have an older hardware version and you install this modem firmware, it will no longer be certified. So we're going to run this command here to look for the hardware version, or you can look just on the physical chip itself. And we can see here that we have the B1 version of the silicon, which means that we can install this firmware and it will still be certified. If you have the B0 version and you install this, it will no longer be a certified chip, but you can still use it for development. So we're going to come up here and we're going to select our JTAG debugger, and we're going to select, so actually we got to download the firmware from the website. I just looked up the NRF 9160 development kit and went to the downloads page where you can see here the modem firmware, newest version 1.3.5, which also tells you about which hardware version you need as well as the change log. So we're going to download that. We're going to connect to our J-Link. We just downloaded our firmware, so we've got the zip file selected, and we're going to say write the firmware. This should take about 50 seconds or so to flash the new modem firmware. We've successfully installed the new modem firmware. We should be able to come back to our LTE link monitor, and we might need to power cycle the development kit. And we can run our software version command again. And if you had a earlier version, you should see the new version of firmware returned after you run this command. Fantastic. So we've shown you how to build a application in Rust for the NRF 9160 in our last video. And in this video, we showed you how to set up a debugging probe, how to flash that application to your development kit, and how to use the LTE link monitor to help debug your device connecting to a cellular network, which can be one of the harder things to do when you are setting up an IoT device. In the next video, we'll be looking at our sensor stream program, and we'll be using the CoAP protocol to send data to the Goliath IoT cloud.